Today what we're going to do is we're going to learn the different states of matter and how the particles are arranged in the states of matter. Go ahead and take a look at the simulator that's on the screen, and I want you to ask yourself, does this represent a solid, liquid, or gas? If you take a look at the particles are nice and orderly. They're stationary, not moving around. They are vibrating. They do have some motion, but relative to each other, they're not moving around. This happens to be a representation of a solid. And if you notice, the big thing with the solid is that it has a definite shape. The particles are, for the most part, stationary, and they're not moving around. If you take a look here, this next one represents a liquid. This, you can see that the particles are moving around. They are, in fact, not in one place. However, notice how they don't fill the container. They're only filling the part of the container that they're occupying. And so this next one here is actually a representation of a gas, and you can see the particles are moving around, filling the whole container. And so these are the three different states of matter that we're going to talk about today. Now, before we go on to the notes, I want you to notice a couple things. First off, notice what happens if I heat up the particles. Notice how they move more. Notice what happens if I cool them down. Notice that they slow down. And so as you heat things up, something that I want you to keep in mind is that the particles will actually move more rapidly. So let's go ahead and go through the notes in the different states of matter. And so what we're going to first do is we're going to talk about the volume and shape that solids, liquids, and gas take on. And so solids tend to have a definite shape and a definite volume. And to give you an example, let's think about this mouse. This mouse is definitely this shape, and it definitely takes up this much space. Now for a liquid has a definite volume. However, it does not have a definite shape. If you think about my coffee that's inside of here, the coffee is taking the shape of this container, but it's only about this much volume that it's taking up. If I were to pour it into another container, it still would only take up this much volume. However, it'll make a different shape based off of the container that it's in. Now let's go ahead and talk about gases. Gases have an indefinite shape, and they will take the volume of their container. So if you take a gas and you put it in a container that's larger, what will happen is the gas will fill the container. If you put it in a container that's smaller, it will fit in a smaller volume. Now let's go ahead and talk about the energy associated with the particles in a solid, liquid, and gas. If you remember from the simulator, the particles of the solid were not moving that much. They had a relatively low amount of energy. Now the energy we're talking about is kinetic energy, which is the energy of movement. So when we say they have a low energy, we're saying they're not moving a lot. However, liquids do tend to move more. They tend to move around. They're able to freely glide past each other. And then gases have even more kinetic energy. They tend to move a lot more rapidly. Now for solids tend to be very orderly. Their particles tend to be nice and lined up. They're not really moving around. And so they have a very high amount of order. Liquids have an intermediate amount of order. They do kind of congregate towards each other. They are able to slide past each other, but they do have some amount of order. And then gases have very little order. The gas particles are randomly all over. They're moving in random directions, and so they have very low order. Now let's talk about diffusion, the rate of diffusion. And before we talk about the rate of diffusion, let's talk about what diffusion is. Diffusion is the spontaneous mixing of particles. And if you take a look at this illustration here, you can see that the red particles are spontaneously mixing with the blue ones. And so that's what diffusion is. Now, solids tend to have a very low rate of diffusion. In fact, it takes a very long time for the particles even to diffuse, if at all. Now, liquids have an intermediate rate of diffusion. If you mix two liquids together, for example, like if you put cream in your coffee, you'll see it actually mixing together, but it does take a certain amount of time. And then gases have a high rate of diffusion. They will mix more quickly than solid or liquid. Now let's talk about density. Density, we're gonna learn a little bit later what exactly density is, but it's how compact a material is, and solids tend to have a very high density. Now there are some exceptions, and we'll learn that later, but for the most part, solids are more dense than liquids. Now liquids have an intermediate density, and then gases have a very low density. So let's go ahead and talk about compressibility. Gases tend to have a high amount of compressibility. Now, to show you an example of that, this is an empty water bottle. It's filled with gas right now. And notice how I can compress it. And if I had super ultra strength, I can compress it even more. However, this water bottle filled with water is not as compressible. It's harder to compress this. You can't do it as you can't compress it as much as the gas. And so those tend to have it's relatively incompressible. It's very hard to compress it. And then solids are definitely incompressible. This right here is a solid. I can sit here and try to compress it and it will not compress. Now the next thing we're going to talk about is we're going to talk about the attraction between the particles in a solid, liquid, and gas. As it turns out, solids tend to have a very high attraction towards each other, and which is the reason why they tend to stick together. They're very attracted to each other. Liquids do have a certain amount of attraction towards each other, which is why they still kind of congregate together and they move around. But gases have a very low attraction to each other, which is why they're able to spread out. If they were attracted together, they wouldn't be spread out, moving all around. And that's all we need to know about solids, liquids, and gases. If you want to, you can go to my website to check out that PhET simulator and play around with it a little bit. If you want to see how the particles interact, there's some other sort of features on there if you want to mess with it as well. Or you can just go to phet.colorado.edu. And that's all for today.